All right, so what questions did you have on recitation 5?
Okay, so I feel like the first part was pretty simple. Then it was the second part where it started with the mapping for genes. Um, so like for the table, for the dihybrid cross, how would I know what to put in for the different numbers?
You're on the short answer, right?
Yes, it's part B, number 1. Right?
All right,
For
so you're on the test cross 1, 2, 3, 4, 5, 6.
test cross. Yes.
Okay.
So like I think I understand like figuring out the order. So since I kept reappearing with the 50% recombination frequency,
Mm-hmm.
I figured out that, all right, I think I is unlinked. And then for AEO, I used like the recombination frequencies to find the distances. And um, so what I think it is it's E in the middle, and then A is 9 centimorgans away from E, and O is also 9 centimorgans away from E.
Go ahead and try one more time. So it'd actually be EOA. So it's going to be O in the middle. Mm-hmm.
So how do you know that?
One moment. Let me go ahead and get our grad TA in here.
Okay.
So Anaissa is going to be joining in just a couple seconds.
Okay.
Okay, what's up? What's the question?
Okay, so for part B on question 1 with the table, I thought I had it, but I don't. So I think with like the recombination frequency with the ones that keep coming up as 50, this is as far as I got anyway. I noticed that I was like the constant in the 3 of those. So from that, I would know I is unlinked, right?
Okay, hold on. Let me say that. Let me open it up. So actually, how do you feel about the whole topic of mapping genes and stuff?
And not the greatest.
Not the greatest. Yeah, because like the whole thing is that I don't want to like just talk about like one exercise, and give you the answer if the whole thing it's not like clear. Mm-hmm. So what about so last semester I did a recitation in gene mapping and linkage. And I have a YouTube video that it's like, I think it's really helpful. So I will send you that, but I can also go over this thing. So let me just download it from Canvas really quickly.
Okay.
Yeah, so after the office hours, you can send me an email.
Sweet.
So I can send you this video.
Perfect.
I mean, and this goes for anyone else in the call, I guess. Hold on. Sorry, it's just that my computer is old and I need to plug it in. Okay. Let me just open it up. Okay. Okay, and this is actually like, I feel that that video is gonna help you so much because I do the exact same problem, I guess.
Okay, sweet.
So I think that should help. But if you want to check answers, right? Or
Yeah. Or
for
just,
which question? Sorry, again.
so question 1 on part B.
Okay, so what did you get?
So I mean, I think that X, or not X, but I is unlinked. That's like
Okay.
right, because from the recitation 5 video, that's what it sounded like. If it had the recombination frequency of above at or above 50, then you know that it's probably unlinked or like super far away on the chromosome, right?
Mhm. So did you get the genotype already, or you're like just stuck there?
So I'm not sure if I have the genotype right, but
Okay.
so like for test cross,
Mhm.
1, I had big A, big E, little e, then crossed with big A, big E, little e. I'm not sure if I did that right.
So it is actually crossed with little a, little a, little e, little e.
Okay, and so would that be the same for all of these then, for the cross just being the homozygous?
Yeah, yeah. And the reason why it's because we're doing a test cross, correct?
Yes.
So whenever you do a test cross, every time you do a test cross, you're gonna cross it with a homozygous recessive individual.
Okay.
Okay, so yeah, basically, you know, yeah, all of the rest are just little, you know,
So
like, yeah.
perfect. But so the first half of that was right with the heterozygous dominant.
Yeah, that's correct. Yep.
So then on number 2, would that
Mhm.
one be homozygous dominant for the first half?
So for the first one, actually, it's also homozygous.
Oh, this is homozygous dominant.
Yeah. So it's big A, big I, little I, and then cross with little a, little a, little I, little I.
Okay. And so how do you know if it's supposed to be homozygous or heterozygous dominant in that case? So I guess that's what was confusing me on this table.
So I think it's just not about like, it's about knowing what a test cross is. Because a test cross, I mean, let me double check if I'm right. But I think a test cross, you always cross a heterozygous dominant.
Oh, okay.
With homozygous. Yeah, so by performing, let me see. Yeah, I mean, I'm not like 100% sure, but I think that a test cross, it's gonna be a heterozygous dominant with a homozygous recessive.
Okay, sweet. That makes that a lot easier then.
I think that is why, because I cannot think, to be honest, another way to know.
Sweet. Thank you. Yeah, that helps a lot.
Yeah.
So then from this table, how would I determine the gene order? Because I thought it would be I unlinked and then A, E, O with E being in the middle, but I don't think that's right.
So actually, okay, so just like by looking at it, like I don't even think they are okay, so let me see, how do I explain this? Okay, so basically there are 3 genes in a chromosome and there's 1 gene in another chromosome.
Okay. I think that's what I was gathering.
Yeah, so do you know which ones are where?
So I think I is in a different chromosome, right?
Yeah, exactly.
So does it matter then? Well, I guess because I think for the next page on the last question, we have to know the order because we have to draw a map of the 4.
Yeah. Mm-hmm.
So I guess that's what I'm confused on.
Okay, so I think basically you would have to get it the same way you've been getting the maps before.
Yes.
Okay, yeah, so you just forget about I guess, and then just based on that offspring that you have there, you should be able to map it with those distances.
Okay, right.
So it says, yeah, so again, you get the number of recombinant offspring over the total, right? Like how we've been doing it.
Oh, so, but since this one's giving us the frequency instead of giving us the number of offspring, wouldn't the frequency be equal to the...
Oh, I'm just in the next table, number 2.
Oh, that's funny. Okay. Sorry,
Okay.
I'm on the first one.
Yeah, so I mean, from the first one, you can see that, well, you just said it, right? Like I is in 1 chromosome and then the other genes are in the other. So then you use this offspring to determine the order and the distance between.
Okay, so that's what I guess the order then. So on the first one, because these questions are building off of each other, right?
Yeah, it looks
Okay.
like it, yeah.
So then would that be the correct order? Because it says the distance between, or the frequency between A and O is 18, which would be equal to 18 centimorgans, right?
Yep, yep.
So wouldn't that tell you that A and O are going to be the farthest apart?
No, not necessarily.
Okay.
I mean, okay, so just looking at the second table, which ones are, so we have 4 different phenotypes, right? So I'm on the second table right now.
Okay.
So we have 4 different ones. So from these 4, tell me which ones are recombinant and which ones are parental and why.
Okay, so the parentals, the 2 largest numbers, which is going to be the top one and the last one.
Okay.
Because they have the highest number of offspring, which means they have the lowest recombination frequency.
Yep.
The combinations are the 2 center ones, so 70, the one that has 76 and 80.
Yep.
Which would have a higher recombination frequency, which we then calculate. So
exactly. So then calculate that distance and you're gonna see that's higher than 18.
Right.
So that's gonna tell you something, right? Like if you look at a map, right? Distance between O and A is 18, but then what about E?
Okay.
So
this one.
So I mean,
okay.
I guess, let me see.
Did I calculate this one?
Okay, so I'm sharing a whiteboard, right? So basically, we have 2 chromosomes, right? And then here we have I, we said, right? And then we have 3 other genes. Okay, so then we said that the distance between O and A right?
O and A, yes.
And actually, let me see, because I myself, I don't understand really good. How do we know?
That's fine.
Yeah, so recombination frequency. Okay, so we have recombination frequency, and let's look at those. So which one has the lowest recombination frequency?
So that's going to be E to O.
So what does having the lowest recombination frequency means?
So from what we've learned so far.
I mean, just if you like kind of understand it, you know, like just logically, right? So when a chromosome recombines the most, it means that it's so far away that there are so many probability that it recombines,
Okay.
right? So that is why if you see everything with I has the biggest recombination. You see that?
Mm-hmm.
And then, so the lowest one is between E and O. So the lowest recombination means that they are so close that it's not very likely that they will get recombined because they are so close. So
Gotcha.
just by knowing that, I know that for sure E is by O. Okay.
Right.
So we put E, like they are beside each other. That's what I can tell just by looking at those numbers.
Sweet.
I can tell that. And then the next little one, it's 18, right?
Mm-hmm.
And that is between A and O. So I can see that A is also beside O. So that gives you the order, okay?
Okay. So how do you know? Wait. So why would O be in the center then?
Just because, okay, so let's do it the other way, right? So what if, so how other way do you suggest?
So what I had was AEO because I thought that the distance between A and E would also be 9 centimorgans as E and O.
Okay, but see, that's what I'm saying, that right now you have just recombination distances between two genes. So right now I just know. So what I know for sure from that table is that between E and O, there is 9.
Okay.
And then between O and A, there is what, 18,
Mm-hmm.
right? So let me see if it would work the other way. So this would be 18. Okay, so I'll tell you why it doesn't work this way in a second.
Okay.
But you're saying like this, right?
Right.
Because how do you get this distance though? I mean,
You
okay, it's okay, so okay, whatever. So let's just have those options as available. So you have option A like this or
Mhm.
option B, right?
Right.
Okay, so now let's just move to the next table.
Okay.
And now let's do the calculation. So for this one, now you have the phenotypes. So now the phenotypes are telling you that the recombinant phenotypes are 76 plus 80, right?
Oh yeah. Okay, I think I just realized that I was doing wrong.
And then over the total, which is, I'm just gonna finish this one so
Okay.
so you finish it. Okay, so the total is 575. So remember, we did these calculations before, right? So this is equal to 0.271,
Mhm.
right? If we multiply it times 100, whatever, it would be 27.1% recombination, okay?
Great.
So if it is 27.1 and I put 27.1 here, it doesn't make sense,
Yeah.
right?
Gotcha.
So what you realize is that it must be this one. Oops. 27.1. And 18 plus 9, is it 27?
Yes. Yeah. You're totally right.
So then this is your final map, okay?
Perfect.
All right. So we just figured that out together because I also was not sure. But that is how you do it basically with the frequencies. And then whenever you map a map, so remember you also need this one, right? So let me just do it pretty. So let me throw it away. Basically, it would look like this, right? So you having one chromosome, you have gene I. In the other chromosome, you have 3 genes. You have gene E, gene O, gene A. Distance between these two is 27.1 centimorgans. Distance between these two is 18 centimorgans, and distance between these two is 9. So this is your answer.
Sweet. Thank you. Yeah,
Okay.
the last part is what I didn't even.
Yeah. And actually, you don't need the video anymore because I thought the video is more for like the first part. So I think you're good with this, right?
Yes. Thank you so much, then.
Yep.
That was all
Alright.
the questions I had.
Okay, great. So now I don't know how to stop sharing. So I'm like in the iPad, so I don't know what I'm doing. Let me see. Okay. Got it. All right. So I see, Michelle, do you have questions, or was that your question too? Because, okay, awesome. All right, so Arshia, we're good?
Yes, we are.
Okay, so, all right, so I think I'm gonna leave now because I have a meeting happening at 9.
Okay.
So I don't think there are any more questions, but I think
Okay.
that was clear. Yeah.
Okay, yeah, perfect.
All right, awesome.
So go ahead and press stop recording.
So it seems that there's no one else in the call, and it seems that Michelle and Nikki already had their questions solved.
Okay.
So yeah, you can stop recording now.
Okay. I think it's mostly because the link wasn't working on the Canvas, so people had to like input it manually. But
Which link?
the link that she posted on her email for this
Uh,
week. It wasn't like directly working, but if you like entered in the number.
the office hours?
Yeah.
Okay, yeah, that's fine. I mean, I think this is
That's
a
what
question that everyone's gonna have. So
mhm.
so it's fine. Just send me once you publish. I mean, you upload. You can stop recording now. Do you stop?